The purpose of this video is to give users new to 3D programming an overview of the various 3D finishing strategies included in HSMWorks. In subsequent videos, we'll look at each strategy in more detail. Now, I have already programmed this part and even saved some custom views to help us navigate through the assembly. With that said, let's get started. The first strategy I'd like to show you is the most widely used 3D strategy, and that is the parallel strategy. Parallel produces parallel cutting passes at a given step over. These passes can be along the machine axes, or as shown here, at a given angle. The parallel strategy works best if the surfaces that are perpendicular to the cutting passes are at a consistent slope. If we were to look at the front view of this part, we'll notice that as we're machining along the top face, the step over is fine, but then when we get to the wall that falls away, one step might run along the wall, and the very next step could be almost a full step over off of that wall, leaving a large amount of material. In the same manner, when we get to steep faces or drastic changes in the slope, the scallop height is also going to change drastically. This is why we need multiple finishing strategies. No one strategy is going to be efficient at cutting all geometric conditions. So we're going to take a look at some of those other cutting strategies. But before we do that, I do want to point out one thing with the HSMWorks high-speed machining strategies. And that is the smooth transitions between the toolpath segments. The smooth transitions that HSMWorks produces allow your machine to run at high speeds without abrupt changes in direction. Moving down the part, we can see an example of a morph strategy and a flow strategy. The flow strategy flows along a surface at a constant step over, while the morph strategy morphs from one profile to another. The contour strategy switches things up a little bit. Contour, which is often called waterline, maintains a constant step down. While contour works very well for steep surfaces, when we begin looking at the top shallow areas of the model, contour becomes very inefficient. In this case, we can use a strategy called scallop. Scallop maintains a constant scallop height. Now, although scallop could be used to machine the entire part, typically it's used as a rest machining operation to get bits of material that are left over from previous operations. Now, before we move on to the radial and spiral toolpaths, I want to quickly show you a ramp toolpath. Ramp is very similar to contour, with one exception. Instead of taking planar step downs as the contour does, the ramp toolpath will ramp down the surface, keeping the tool constantly engaged with the material. Well, I told you the next toolpath type we're going to look at were the spiral and radial toolpaths, so let's take a look. Spiral, as you might imagine, spirals out from the center of a circle. I like to think of it as a parallel toolpath for round parts. As I'm sure you can imagine, the radial toolpath in a very similar fashion radiates out from the center of a circle. The final two strategies that we're going to look at automatically find the geometry that's suited to them. That is the horizontal and pencil strategy. The horizontal strategy automatically finds any horizontal faces and finishes them, while the pencil strategy automatically finds any internal radiuses or sharp corners. Well, that concludes the commonly used 3D finishing operations. But before we draw this video to a close, I'd like to show you two additional 3D operations that can become very useful. Project allows you to take a sketch and project a toolpath based on that sketch down to the surface of the model. And in a similar fashion, the trace toolpath will trace along a selected edge. Well, I know that was a very quick introduction to the 3D strategies. In subsequent videos, we'll discuss each 3D toolpath type in detail as well as methods of keeping that toolpath to areas of your geometry that are ideal for the given toolpath.